Hi everyone, today we are going to start 6.3, which is prove triangles are similar by angle. Quick review. As you remember, angle was not a reason that we could prove that triangles are congruent. So if you look at this column here, these were all the ways that we could prove two triangles were congruent or the same. And this column here was all the reasons why they were not the same, or that we couldn't prove that they were the same. Angle, and side angle. So now angle is something that we're going to focus on in this section because this is enough information to prove triangles are similar. So like I just said, angle is enough to prove that triangles are similar. So in this example, is triangle ABC similar to triangle DEF? Why? Well, if we remember what similar triangles are, similar triangles means all the angles are congruent, and if all the angles are congruent, the side lengths that are corresponding to each other will have the same scale factor. So why is angle enough? Well, we know that if this angle is congruent to this angle, the second angle is congruent to this second angle, the third angle must also be equal to the third angle of the second triangle because all the angles have to add up to 180. So angle is enough information. So determine whether the triangles are similar. All right, so for part A, is this enough information to prove that these two triangles are similar? The answer is an obvious yes. Why? Well, we have a 90-degree angle right here and right here, as well as a 45-degree angle. So angle is enough to prove that those two triangles are similar. Part B here, is there enough information? Well, I do see that we have two 90-degree angles. I see that this angle is 26 and this angle is 64. So to be able to prove if these are similar, I need to figure out what is the measure of angle E and angle G. Remember, when you add up the angles in a triangle, what do they add up to? 180. So if I look at the first small triangle, that means angle E has to equal 64, and angle K has to equal 26. So yes, there is enough information here, and why angle. All right, see here. Is this enough information to prove that these two triangles are similar? Yes or no? So if I look here, I notice that this angle here is 52. This angle here is 52. So I do have angles that are congruent. Looking at this triangle, though, there is another angle that they both share or both have in common. Which angle is that? Angle A. So we have the small triangle here, which includes angle A, and this large angle here, or large triangle, which also includes angle A. So this would be the reflexive property. They both share angle A, so that means that they are congruent to each other with the reflexive property. So is this enough information? Yes. Why? The angle similarity theorem. For part D here, is this enough information to prove that these two triangles are similar? Well, looking at these two triangles, all I see is that these two sides are parallel. Well, what does that mean? It means that their lines, or those lines will never cross. So now, if we have parallel lines, I also have a few transversals, so I'll just kind of focus on this one here. We have a few angle pairs. So one angle pair would be this angle and this angle. Why do I know that those two angles are congruent? They're vertical angles. So I know that angle SVR is congruent to angle UVT. Why? Because they are vertical angles. I also know that angle S is congruent to angle U. Why do I know that? Well, they are alternate interior angles. So angle S is congruent to angle U. Why? They are alternate interior angles. So is this enough information to prove that these two triangles are similar? Yes, it is, by the angle-angle theorem. This is the last problem that we will do. So we're going to use the diagram to complete the statement. Triangle ABC is similar to which triangle? Well, let's look at our diagram. I know that these two triangles are similar because of the angle-angle theorem. This angle C is congruent to this angle F, and this angle A is congruent to this angle D. So angle-angle is enough information to prove that these two triangles are similar. All right, so triangle ABC, remember order matters. So it's going to be congruent to triangle which corresponds with A. It would be D. What corresponds with B? Well, B is right here, and that corresponds with E, meaning that C is going to correspond with F. So triangle D, E, F. For part 2, we have a few ratios going on here. So let's kind of think about what we discussed in the last section. When we know triangles are similar, we know that their sides are proportional. Now if I look at AB and the top of this fraction here, AB would be this side right here. Which side corresponds with side AB? It would be DE. So DE is going to go in the bottom here. All right, so now we see EF in the denominator, which it should be because it's talking about the large triangle. So the large triangle EF is this here. Which side length corresponds with EF? It would be BC. And CA is this side here, which means it corresponds to FD. Part 3, angle B is congruent to which angle? So angle B is right here, which means it corresponds to angle E. Number 4, blank over 12 is equal to blank over, 8 over blank. So 8 is here and 12 is here. All right, so since 8 is with the small triangle, that means since 12's in the denominator here, I need to see which side does 12 correspond to, and I notice that it corresponds to X. So X needs to be here. So 8 is in the lower hand part of this triangle. What does it correspond to with the large triangle? And I see it corresponds with Y. So the answer is X over 12 is equal to 8 over Y. So what is X equal to? Since there was a lot of things going on in my picture, I erased it so it's clean now. So we want to figure out what would our proportion be involving X. So I'm going to circle X here. Well, which two sides of these triangles do we know for sure? Well, I know that this side here corresponds with this side here. So let's write a ratio, and remember it doesn't matter which order you use because you get the same answer. So I'm just going to use 6 over 16 is equal to, well, since I use 6 first, I have to use X first in my next ratio. X over, and what corresponds with X? It would be 12. So now that I have my ratio, I'm going to use cross multiplication here. So 16 times X is 16X. 12 times 6 is 72. Divide by 16, divide by 16, which means that X is equal to a fraction 9 over 2. And if you plug 9/2 in your calculator, that's really 4.5. All right, so next we need to figure out what is y. All right, so y is in this triangle here. So once again, the only two sides of the triangles that we know for sure, or that are pretty numbers, I'm going to use these again. So my ratio would be 6/16. I'm going to use the same one as I did for my last answer, is equal to. So now y compares to 8. Since I use 6 in the numerator, I'm going to need to use 8 in the numerator for my second ratio. That's going to be divided by y. We will cross multiply, so y times 6 is 6y. (16 times 8 is 128. Divide by 6, divide by 6. Now, when you plug this in your calculator, you'll get 21.3 repeating. So that's not really a nice, pretty number. 4.5, that was a nice decimal. So since we have that 0.3 repeating, you can't really round that. If you do round, it wouldn't be an exact number. So I'm just going to simplify 128 divided by 6. It does have a simpler fraction, which would be 64 divided by 3. And so that would be my answer for that.